Once again, welcome back to our channel. That since now we have covered so many topics in the physics of the first chapter of your class 12, and in continuous to this, I just want to continue the electric field intensity. No doubt we have covered 2 classes for the electric field intensity. Rather, there is a lot of topic we have to read. The basic concept we have the electric field intensity we just got in the 2 videos. And in addition to this, there is the most important is the characteristics of the electric field intensity. What is the characteristics of the electric field intensity? First, we know the electric field intensity is the word can be replaced as the electric field, or the word electric field can be used by the electric field with the electric field intensity. Anyhow, what is electric field intensity? The first characteristic is what is the electric field intensity? Electric field intensity at a point in an electric field is defined as the force per unit area at that point. Electric field intensity at a point in an electric field is defined as the force experienced by a unit positive charge at that point in an electric field. That means what? If this is an electric field, this is a source charge, it is a test charge. The force experienced this unit positive charge, the force experienced by the unit positive charge per unit positive charge will give the electric field intensity. Means simply we can say E is equal to F by Q. In addition to this, later on when you will read about the electric potential, then you will also gain another topic regarding the relation with the electric field intensity. Is the electric field intensity is the negative gradient of electric potential. Means the electric potential V is the minus dB by dL will give the electric field intensity. Means from this we can conclude that the electric field intensity have 2 definitions. One is the electric field intensity is defined as the force experienced for a unit positive charge or per unit charge in an electric field at a point. And second is the electric field intensity is defined as the negative gradient of electric potential. And the third point is it is a vector quantity. Why it is a vector quantity? I already said you any quantity can be said as a vector quantity if it possesses both magnitude and direction. That means what? It has the magnitude. In addition to this, it has the direction also. What is the direction? The direction in which direction the force is applied, the direction of electric field intensity also is the same. And the fourth point is that about the electric field intensity, the dimension and the unit. What is the dimension? We know electric field intensity E equal to F by Q. Then we can say the dimension of F is M1 L1 T minus 2 by Q means A1 T1. That means what? The electric field intensity dimension M1 L1 T minus 3 A minus 1 or A minus 1 T minus 3. This is the dimension of electric field intensity. The same way, now we will discuss the unit. We know E is the electric field intensity, F by Q. F means what? Newton per charge is the coulomb. Newton by coulomb will give the unit of the electric field intensity. In addition to this, if you will multiply meter in both numerator and denominator, Newton and meter will give the joule per coulomb into meter. This also will give the dimension of electric field intensity. Another dimension of unit of the electric field intensity. In the same way, if Newton into meter by coulomb into meter, this Newton into meter will give the joule by coulomb into meter. We know that volt is the work done per unit positive charge. That means what? Joule by coulomb will give the volt by 1 by meter. That means this will be volt per meter, will also give the unit of electric field intensity. Means what we know since now, the definition of the electric field intensity. Second, it is the vector quantity. Third is the dimension m1 l1 t minus 3 a minus 1, and the unit is the Newton per coulomb, joule per coulomb into meter, and volt per meter. These all are the dimensions of electric field. So dimension and unit of the electric field intensity. Now that we know, as see, whenever the charges or the test charge is the position of test charge will give the electric field intensity. Means what? If we change the position of the test charge, what is the impact on the electric field intensity? Actually, we know that it is a position which gives the electric field intensity. Means in this position, what is the electric field intensity? Means here the value may change with the change of the position of the source test charge. In the same way, if you approach to the source charge, there may also the change in the electric field intensity. Means it clearly indicates that this distance will changes the electric field intensity. Means if you say this is the R, if R increases, then electric field intensity will also decreases in rapid manner. That's why electric field intensity is inversely related to the square of the distance between the source charge and test charge. That means what? E inversely proportional to R square. Means if you draw a graph between the E and R, in the x-axis if you take E, in the y-axis if you take the E, and in x-axis you will take the R, then the graph in such way. In the same way, as in these two mediums there is a relative permittivity, due to which also the electric field intensity will change. Means the electric field intensity changes basing on the two things. One is the position of the test charge, and second is the relative permittivity between the source charge and test charge. Okay. Next is the in a conductor. Let's take this is a conductor. In this conductor, in the surface of the conductor, the current flows. Means charges are present in the surface of the conductor. That means what? In the inside of the conductor, there will be no charge. It indicates that there will be no electric field intensity within the conductor. These all are the characteristics of the electric field intensity. Just I am repeating all the characteristics of electric field intensity. First, electric field intensity can be defined as the electric field intensity at a point in an electric field, the force experienced per unit positive charge at that point. First. Second, electric field intensity is the negative gradient of electric potential in an electric field. Third, electric field intensity, the dimension of the electric field intensity is the m1, l1, t minus 3, a minus 1. Fourth, the unit of the electric field intensity. First is the Newton per coulomb, second is the joule per coulomb per meter, third is the volt per meter. Fourth, the electric field intensity varies inversely with the square of the distance between the charges. And next point, the electric field intensity inside a charged conductor is always zero, as there is no charges within the conductor. And in addition to this one, why this is zero and what is the impact of this one? These things will learn in the electric lines of force or lines of force. Dear students, I would like to request, please note the question for the electric field intensity. We will do the numericals for this. I request you to pause the video and write the question. Then we will start the answering for this. I think always wrote the question or noted down in your notes. First of all, you just read the question what you have written. In the question it is given two charges. One is the 10 microcoulomb at point A. Another charge minus 10 microcoulomb at point B, which are separated by a distance of 10 centimeter. Separated by a distance of 10 centimeter. Find the electric field intensity at point P. This is a point P, which is on the perpendicular bisector of AB. Just will draw. This is the perpendicular bisector of AB. Let's think this is the point O. This will bisect the AB, means this will be 5 centimeter. This will be 5 centimeter, which is at a distance of 12 centimeter. Now we have to find the electric field intensity at point P, which is in the middle of this point P is separated by distance of 12 centimeter from the middle of AB. Means if I put this name as the O, then we will find the electric field intensity due to at the point P. Remember, electric field intensity we are finding for a source charge. Means what? We cannot find the electric field intensity for the two charges in a single shot. That means what? We have to find the electric field intensity for point A. Then we have to find the electric field intensity for point B, and then we have to find the electric field intensity or the resultant intensity. That means what? The electric field intensity due to the point A can be say this point B, this is electric field intensity. This will be EA, and from P this will be EB. Remember, lines may bend due to the drawing by only with the hand. Okay, just you manage by the drawing by the scale. Okay, electric field intensity due to the point A is the EA, and see the direction. The direction it gives the EA is in this direction and EB is in this direction. Why is so? Actually, what happening? Electric field intensity due to the point A. Generally, the test charge we are taking the positive charge. Means these two charges may repel with each other. That's why the electric field intensity gives in this direction. And for the point B, this is a negative charge. The electric field intensity due to these two charges may attract with each other. That's why the direction is gives in this direction. For which now we are finding the electric field intensity at point P. See, for electric field intensity, what we know? What is the formula? E is equal to 1 by 4 pi epsilon 0 Q by or 1 by 4 pi epsilon naught Q by R square. What is the Q? This is 10 microcoulomb. 1 by 4 pi epsilon naught is the 9 to 10 to the power 9. And what about the R? R is the distance from A to P. How can we find the AP? See, AP we know AP equal to BP. Why? Why AP equal to BP? Because this AO and OP are both have the 5 cm and 12 cm, as like the BO and OP. Using the Pythagoras theorem, you can say this: if it is a 5 cm and it is a 12 cm, the value what will get? The same way that if this is the 5 and this is 12, the same value will get here. That means what? AP equal to BP equal to 5 square plus 12 square is the 25 plus 144, which will give the root over 169 is 13 centimeter. Means we got the value of R. Now we will find the electric field intensity at point A. Electric field intensity at point A. EA equal to 1 by 4 pi epsilon naught Q by R square. This means 9 into 10 to the power 9. Q means 10 microcoulomb, micro means minus 6 coulomb, by R means 13 into 10 to the power minus 2 whole square. Why this is 10 to the power minus 2? Because we are using the SI units. SI unit is a meter is a, that's why this will be 9 into 10 to power 9 into 10 to power minus 5 by 169 into 10 to power minus 4. If you solve the value, then you will get this one as the 5.3 into 10 to power 6 Newton per coulomb. See, the value of EA is same as the EB. Why? Because all the parameters you can see both are same. Only the difference is this is the repulsion force, this is the attraction force. That's why, therefore, I can write as the EA equal to EB equal to 5.3 into 10 to power 6 Newton per coulomb. Now we can find the electric field intensity. What is the electric field intensity or resultant electric field intensity? This is the resultant electric field intensity. We can find this as the using the Pareto law of vector addition. See, if this is these two are the vectors and this will give the resultant field as using the Pareto law of vector addition, and this will be the cos components. EA will be, this component will be cos component and this will be the cos component. Then we will find the electric field intensity or the resultant electric field intensity. For space, I will erase this part. This resultant electric field intensity E vector equal to EA cos theta plus EB cos theta. This will be EA plus EB into cos theta. You might have the question, where is the theta? But you know, this is the theta and this is the theta, and then this will be theta and this will be theta. See, these two lines are parallel. Then this will be these two are the corresponding angles and these two are the alternate angles. Then the cos theta becomes EA means 5.5 into 10 to power 6. Sorry, 5.3 into 10 to power 6. This will two values are same. That's why 2 into 5.3 into 10 to power 6. Cos theta will be the adjacent by hypotenuse. Adjacent is the AO by AP. This will be 2 into 5.3 into 10 to power 6 into AO means 5 by 13. If you solve the value, you will get 4.1 into 10 to power 6 Newton per coulomb. This is the resultant electric field intensity. And remember, this is the question for the sake of understanding for you. I will give the 2 more questions to do in your home and understand the question. Try to solve the question. If there is any doubt, you have to solve the question and ask me. Is there any doubt? Ask me. I will solve in by the message, or I will create another video and you will watch and you will solve likewise some more questions. My dear students, I would like to request, please pause the video and write these 2 questions to practice and solve the questions. And see, the first question gives about the continuous charge distribution. As you know, what is the continuous charge distribution? I think most of them gone through the textbook where the continuous charge distribution is given. To find the electric field intensity due to the continuous charge distribution, you have to use the integration method. Means from the first question you will use the integration method and you will solve this one. And for the second question, that I already told you that electric field intensity for a point charge, you have to find this one. See, the 2 spheres of charges 10 plus 10 and plus 40 coulomb is given. Means plus 10 coulomb and plus 40 coulomb. And where the intensity is 0, that you have to find. Is there any doubt? Contact me and I would like to solve you individually. Thank you. Okay students, I think all were gone through completely about the electric field intensity, which is one of the most important topic for the physics, and basing on these topics we should know the so many concepts. And remember, the electric field intensity is one of a concept basing on which we can find so many numericals. That's why I request you, by solving apart from these 2 questions which I have given you, you have to solve some more questions also. And in continuous with, now we'll jump to the another topic today. the already you have lot of topic to the now until the electric field intensity or the lot of concept in the electric field intensity. Now we'll go through the electric lines of force. What is electric lines of force? See, what is electric lines of force? In simple we can say this is also related to the electric field intensity, or simply we can say electric field. This is a, simply we can say, if it is an electric field is there or anywhere the electric field is there, generally the electric field is due to the a charge or one more than one charges. Whenever we put a unit positive charge in the electric field, it is asked to move in a particular direction or path. This path or the direction gives the electric lines of force. On simple way I can say, on account of the electric field intensity in an electric field, a point charge is asked to move in a definite path. This path will give the electric lines of force, and this path may be due to a single point charge, may be due to the more than one point charges. Understand? See, is the path straight or curved? That depends on the whether this is a single charge or more than one charge. If the charge is 2 or more than 2, then the path should be the curved, and the tangent drawn at any point on the curved or the curved line will give the direction of electric field intensity. That means what? If a path is straight, that is the direction. If it is a curved, what is the direction? For every point we have the direction, only we have to draw the tangent there. And you know, in the circular line, you know, in the class 9th, what was the circular motion? In the circular motion, if you keep at any point, if you draw any point, at any point, if you draw a perpendicular or the tangent, that will give the direction of the direction. In the same way, in here also, if you draw a tangent at any point in the curved path, that will give the direction. Now what we read first is the what are the electric lines of force. Electric lines of force are the lines of force on account of the electric field intensity. A point charge is asked to move in an electric field in a definite direction of the path. This path is gives the, this may be straight or curved. When it is free to do so, means when it is freely, it will be moving in a definite direction. That direction will give the electric field, electric lines of force. And what are the properties of the electric lines of force? First is the property, if this is the positive charge or single isolated positive charge, then the path will be in such way, means it is outward. If this is a negative charge, this will be approaching or towards. Understand? If more than one charge, let's take this is a positive charge and this is a negative charge, then charges will be in such way. This is when it contracts longitudinally, and when both are the opposite charges, then both are the same charge. It may both are positive, this may be negative. this will contract lateral. Means when both are the positive charge or the same charge, they will repel with each other. That's why they will contract laterally. When both are the opposite charges, they will contract longitudinally. This is the isolated charge, and here the more than one charges. And now next point is that if it is a curved path in such way, the tangent drawn at any point will give the electric field intensity. The tangent drawn at any point if it is a curved path, the tangent drawn at any point will give the electric field intensity. And remember, the most important point is that the two electric lines of force never intersect with each other. Why? The most important question. The two electrical intensities, the two electric lines of force never intersect with each other. Why? Because see, let's think these two electric lines of force are intersecting with each other. Then at the same point we can draw the two tangents. One will give the E1, another one is the E2. Means at the same point two electric field intensity will arise. This is impossible. That means what? The electric lines of force never intersect with each other. Again I am saying, let's take the two electric lines of force are intersecting with each other. Let's take at point P. If at point P both are intersecting with each other, at the same point two electric lines of force two electric field intensity will arise. These two electric field intensity E1 and E2. Both the two electric field intensity cannot be possible, or it is impossible. That's why they never intersect with each other. And next is the see, if I will compare at this point and this point, here or here, in this point the electric field intensity is more as compared to here. Why? Because the number of electric lines of force, is more in this place. Means what? The electric lines of force is proportional to the electric field intensity. Means you may say a single unit positive charge in air give the 4 pi electric lines of force. Again I am saying, a single unit positive charge in A will give the 4 pi electric lines of force. Understand? Next, fourth is that if a spherical surface is there, the electric lines of force will meet normally. Why? Because if it is not so, then the sine component will be parallel to the surface, which is impossible. That's why it meets normally to the spherical surface. And fifth point is that whenever in a conductor, if you see, in a conductor there is no current, there is no charges within the conductor. Means there is no electric lines of force within the conductor. Means another thing, the electric lines of force never intersect within the conductor, and simply implies that this space is completely charge free. Means this outside is the charged body. This is a charged body, but inside there is no charge. Means there is absence of charge, and that's why the electric lines of force never enter into within the conductor. Means what we can understand, this is the electrically sealed. Means within any object is there, if there will be outside there is charges are flowing, within the objects there will not be impact due to the charge. It is completely shielded by the outside surface. These all are the properties of electric lines of force. Now we'll understand the electric dipole. What is electric dipole? It is a combination of two charges. Two equal and opposite charges are closely placed with each other. Think two charges Q plus Q and minus Q, both are closely at some distance apart. Let take this distance is the D distance. Then this is called the dipole. You understand? Di means two, pole means two ends of the poles. Okay, means positive charge and this is negative charge. These are the two poles and these are separated by some distance. This is called the electric dipole. The middle point of the midpoint, which are equidistant from the 2 point charges, is called the center of the electric dipole. Again I am saying, what is electric dipole? Electric dipole is the combination of two charges are closely placed with each other. And see, Q1 is plus Q and minus Q are the two charges are closely placed and separated by a small distance. And this point is the middle point of these two charges, which is called the center of the dipole. Now we'll learn about the axial line. What is axial line? It is a line which is joining the two charges and passing through the center of the dipole. Again I am saying, what is axial line? It is a line which is joining the two charges and passing through the center of the dipole. And next is the equatorial line. Equatorial line. It is a line passing through the center and perpendicular to the dipole, and if you take any point on this line, you will see these points are equidistant from these two charges. Means this distance is same as this. Means these two distances are same. If you take any point on this line, all the points are equidistant from these two charges. This is called the equatorial line. Now we understand what is axial line, what is equatorial line. Now we will understand what is the electric dipole moment. We will see the electric dipole moment. What is electric dipole moment? Electric dipole moment is the product of charge of any of the charge, or electric dipole moment is defined as the product of the charge and distance of separation between them. Means it is represented P. It is a vector quantity. P vector equal to Q into 2A. Q into D. It is the separation distance is the D. That's why this is the product of Q and D is the electric dipole moment. It is a vector quantity, and this direction is same as the direction of electric dipole moment is same as the force experienced between these two charges. That means what? The electric dipole moment is the product of the charge and the separation distance between these two charges. And next is what is ideal electric dipole moment. The ideal electric dipole moment, is when the charge will be the infinity and the separation distance is the 0. Means ideal electric dipole moment when the charge tends to infinity and the distance between these two charges tends to 0, then the product of these two values will give the ideal electric dipole moment. Understand? Now I would like to request you to please go through all the topics since now we have taught. I have taught you. Then just read all the topics from your textbook and take a note and do some questions from your exercise and take some questions from your other reference material and read, solve some more questions or some more numericals, and in continuous with the physics you may read the other subjects which is very essential for this period. And once again I will request you to please stay home, please stay safe and read well and learn more. Thank you. And once again I request you to all please subscribe to our channel and to see all the videos or see all the updated videos, and please make the material for you. Thank you all of you.